好，那我们就开始上课了啊。这个欢迎同学来啊，欢迎同学今天来我们的 seminar 啊。我们今天 seminar 是请到这个美国 UI 选片啊 ，Urbana-Champaign 对，在美国 UI 选片的一位教授汪洋教授啊。汪洋教授是在2010年在美国加州 UC Irvine 毕业的啊。后来又去这个卡内基梅隆啊，卡内基梅隆研究了2年啊，后来还到 Syracuse 去啊，刚才跟我讲的，还到 Syracuse 去啊，反正他有很多的经历啊，到各个学校都去做一些取经啊，研究取经，然后现在的目前的工作是在 UI 啊 UI University of Illinois 吧。对 University of Illinois is Urbana-Champaign 啊。那今天要讲的题目是这个 Democratic AI Governance and AI Safety for Youth 啊。那么欢迎汪教授。
Hello. Okay, thank you, Professor Yang, and special thanks to Dean Chen for the invitation, and I'm very excited to be here. So I prepared my talk in English, so please bear with me. So today my topic would be about ethical AI. Obviously, AI is fast growing, and we're all very excited about all the kinds of developments. But hopefully, one thing I hope you can take away from today's talk is that as many of you, when you graduate and work for an AI company, you should ask yourself, how can I build the AI product so that the broader population will benefit from it? So today I'm going to give you some negative, some pretty tragic cases where AI applications went wrong. And hopefully we can create countermeasures to make sure that the AI products we develop can really benefit a wide range of users and the society at large. Okay. I'm from UIUC, and I'm a co-director of the Social Computing System Lab, what we call SALT Lab. Okay, so this is no surprise. AI is making waves in so many ways. And here I will just show a couple of examples. Probably some of these you're familiar with. How many of you have heard of AlphaFold? Okay, many of you. So this is DeepMind's answer to automatically predict 3D structures of genes. So this is considered a breakthrough in drug discovery. So one of the successful examples of AI for science. And I don't know how many of you have been playing with ChatGPT. So in the past month, a lot of my social media channels are flooded with pictures like this, where you can automatically generate a Japanese cartoon style picture. And can somebody guess which one is me in this picture? Yes, so I'm number 6. Thank you. However, what I want to draw your attention is that AI can also have negative impact. So this is one of the kind of infamous examples where a journalist from Wired did an experiment, and what they want is they want to see how the OpenAI Sora model, so Sora is a text-to-video model. So you give a textual prompt, and you would generate a video automatically. So the journalists were curious if you provide underspecified prompts. So for example, generate a video for a CEO, or generate a video for a college professor. So they were wondering what kind of video this model would generate. And lo and behold, so they did this multiple times. So if I just say, generate a video for a professor or for a CEO, 100% of the trials, they always get a male character in that video, which obviously is a problem. So it kind of perpetuates some of the existing stereotypes and biases. So perhaps the way they train the model, probably using very unbalanced data set. But this is one of the examples. And of course, you might even have more dramatic cases where this is one of the cases where Tesla's Cybertruck, I haven't seen this here in Taiwan, but it's quite popular in the US. When it's under the self-driving mode, it actually crashes itself. So as you can see, it can be dangerous. It's not frequent, but it's but when it occurs, it can be very dangerous. And then in the educational domain, I have kind of a minor, severe case where these are high school students in Sydney, Australia. They have to retake a test because when they took the test, an AI auto spell checker was triggered, basically invalidated all the test answers the students gave, so they have to redo it. And later in the second half of my talk, I'm going to give you a more dramatic example. Okay, so, but my point in showing you these examples is that there's a pretty obvious trend that in recent years, as AI advances, we're seeing an increase in what's called AI controversies. So these are incidents where AI became problematic, like the self-driving car crashed, or you have a biased model. So as you can see, so I did not create this graph myself. This was a graph included in the Stanford University has a Human-Centered AI Institute, and every year they published an annual report on the AI landscape. So they looked at what companies are doing, what academia is doing, and the AI safety is one of the areas they cover. So this is a picture from their latest report, even though it's 2023, I believe their 2024 report has not released yet. But you can see a clear uptick trajectory, and I bet you if you plot the 2023 and even to today, you're going to see an even higher bar for these incidents. Okay, so I would like to pose this question, which is, who decides how AI should behave? So right now, the status quo is that the companies, they decide how the model should behave. But is that really a sufficient answer? And I would suggest that we should challenge that status quo. So let me give you a concrete example. So there is a very popular app called Be My Eyes. So for now, let's just say it's called Be My Eyes. So this is a very popular app among blind users, so users who cannot see. And the utility of this Be My Eyes app is that if you're a blind user, you take a picture, but you want to know what's inside the picture. So what Be My Eyes does is that under the hood, there is a pool of volunteers, humans. So they will be getting these pictures and they can answer what's inside the picture. And then they'll explain that back to the blind user. So it becomes a very popular tool for blind user because it improves blind users' independent living. So they don't have to ask friends. They can just ask these volunteers through the app. And fast forward to about 2023, when ChatGPT was invented and launched, OpenAI and Be My Eyes, they joined force. So they collaborated. And specifically, OpenAI would like to make this app more intelligent. So the way it makes it more intelligent is that now if you are a blind user, you post a picture through the app. The AI will tell you what is the, thank you. AI will tell you what's inside the picture rather than a human being. Because nowadays, image captioning is a pretty solved problem. So AI would be able to do this. Okay, so, but one thing that's really interesting about this case is that OpenAI made a policy. So OpenAI imposed a rule, and the rule says, as part of the beta testing, OpenAI engine may blur faces or omit facial descriptions if a person is in the picture because of legitimate privacy considerations. So if you read it, it seems quite reasonable, right? Because if a picture contains a person, they don't want to reveal the person's identity. That's why they call it privacy consideration. And if that's the case, basically the AI engine would refuse to provide captioning. So that was a policy. That's how this app or this AI model was governed, just by OpenAI. However, soon after they incorporate this AI feature, there was a backslash in the user community. So the blind user, they were really angry about this policy because one of the main reasons why they use the app is that they want to get captions. And a lot of times the pictures do contain people inside the pictures. But now OpenAI basically refused to give you caption, which negate the utility of this app. And that's why people are leaving, they're just creating this app. So my point is that, and this is a real world example where if how AI should behave is only governed by the company, then it might actually backfire, and then you can actually just piss off your users and people will stop using it. So the point is that you should engage the broader user group or the population in deciding how AI should behave. Okay, so I would like to suggest that we need better AI governance models. So before I dive into this, I wanted to offer a working definition of what I mean by AI governance. So the first paragraph is a recent paper where they give a definition of enterprise AI governance. You can read all this, but basically it says that AI governance for a company is a combination of rules, practices, processes, and technologies that will support the organization's strategies, objectives, and values, also legal requirements and ethical principles. The second paragraph, or the second sentence, in the bottom, is a very recent literature review paper where they looked at all the papers are related to AI governance. And one of the key findings for this paper is that they realized the current AI governance approaches is lacking human involvement. So this kind of goes back to the example I give. Most of the time, when we decide what AI should behave, that decision was made by the developers, single-handedly. They were made by those companies, where the user population or the general public was not really asked or providing feedback in that process. Okay, so now I want to talk about this project we worked on. I think it was in the summer of 2023, OpenAI realized this was a challenge. This is a problem, right? If they always decide how ChatGPT or other AI models they created by themselves, it's likely that they're going to get criticized by the general public because of the various issues we've been talking about. So OpenAI see this as a challenge, but they also see it as an opportunity. So the question is, how do you solicit feedback or inputs from the broader public about how AI should behave? So in order to do this, OpenAI created a call for proposal. That's in academia, that's how we like to call it, but you can even think about it as an open competition. So they have an open competition. They invited anybody around the world to propose ideas where they can use the method to solicit what they call democratic inputs to these AI models. And long story short, I think there were about 800 teams around the world who submitted their ideas, and my group was one of those, and we were fortunate to be selected as one of the 10 winning teams around the world. We were really excited. So now I'm gonna introduce you to our team and our project. So this is our team. It's mostly folks from UIUC, and then we have colleagues from UC Berkeley, as well as Stanford. One thing I like to highlight is that this is an interdisciplinary team. Some of us are computer scientists. Some of us, for example, the folks from Stanford, they were actually social psychologists. So they were psychology experts. But joined together, we want to create a socio-technical solution to this problem. And we call our platform inclusive.ai. And our goal is to build a platform so we can engage underserved populations in making those decisions about AI. Okay, so let me give you a 3,000 feet view of what this platform does. So when OpenAI first launched that program, one of the examples they give is this one, this picture shown on the left. So this is an image generated by a very simple prompt, which simply says, a nurse helping a CEO. So imagine that you query this, this text-to-image generator, and you say, generate an image which depicts a nurse helping a CEO. And that's it. That was the simple prompt. And then you get this picture. So the AI generates this picture. So I'll give you like 10 seconds for you to look at this picture. And then I want to ask you, do you think this picture is appropriate or not? So raise your hand if you think this is not appropriate, we should change it. Thank you. I think it's still the minority. A lot of the professors, I think you raise your hand. But I think other students, maybe you're still considering. But anyway, the question OpenAI posed was, would you want this to be presented in a different way? So obviously, this picture might, represent some stereotypical biases. Like for example, if you say a nurse, oftentimes it would depict a female, or a CEO would be a male. So that would be, a stereotypical bias. But if the users, the participants, or the the user community or the general public, when they see this scenario, we want them to discuss exactly this question. Do you think this is an appropriate picture, or do you think we should change it? So they're going to discuss. Obviously, everybody might have different opinions, but ultimately, we want them to converge on some consensus. So it's a bit of a deliberation and consensus building. And eventually, at the end of the process, right here, consensus, we want people to vote. We want people to vote on what they think this AI model should do. So here I'm just giving you a very simple list of 4 options. So, everybody can pick one of those. So the first simply is just the AI model just keeps the current status, so it doesn't change. The second is, okay, maybe the AI models can consider additional information about the user who made the prompt, who submitted the prompt. So maybe you can consider the user's demographics, right? Gender, age, occupation, so on and so forth. And the third option is maybe the AI models could keep track of the past interactions this user had with this model and maybe learn the user's preferences and then apply the preferences automatically. And then the fourth one is maybe the model would allow the user to add specific tags, like maybe make this prompt even more specific. So those are kind of the toy examples for voting, but ultimately this group of users, they're going to discuss this scenario and then they'll go vote on what the model should do. So pretty simple process. And by the way, anytime if you have questions or comments, just please let me know. I'll be happy to address your question. Okay, so at a very high level, this kind of summarizes our approach. So we were inspired by this phenomenon that's called decentralized autonomous organizations. So I don't know how many of you are familiar with cryptocurrencies like Bitcoins or Ethereum or Dogecoin. So this idea of decentralized autonomous organizations, or DAOs as we call it, is a is like a social phenomenon enabled by blockchain technologies. Okay, so it's decentralized and autonomous. What that means is that there's no central authority that dictates how the organization should behave. So in the AI context, right now the status quo is that you do have central authority. OpenAI for OpenAI's product. They're the central authority. They decide single-handedly how OpenAI models should behave. But in the decentralized organization, there's no centralized authority. It's really the individuals who are part of the community. They're going to jointly decide the behavior of the organizations. Okay, so in DAOs, so we actually studied more than 100 DAOs in the real world. In the real world, this is a thing. So it's not a made-up phenomenon. It's actually a real-world phenomenon. There's thousands of DAOs, and typically when we think about these DAOs, you can think of it as a group of strangers. They can be from anywhere, but they share some sort of interest. So it's a group of strangers. It's like a Slack channel with strangers, but they share a crypto wallet. So they have some resources. Right? They can buy things, they can do things. But they're, as part of this DAO, they have to figure out, how they make decisions about what the DAO should do, what, an organization should do. So the way they do it is they have these decentralized governance mechanism, like different kinds of voting schemes that I'll talk about. And so we just studied DAOs as part of another project, and we realized that this very nature of decentralization actually may be quite useful in making things democratic, because you don't really have a centralized authority to dictate the decisions. So we explore various kinds of decentralized governance mechanism in this AI decision-making process. And we believe this could be a useful thing to engage diverse, underserved populations at scale. Okay, so let me give you a quick example of a real-world DAO that is pretty successful. So this is a DAO called Compound. So Compound. And what you see on the left is a flow diagram. So this flow diagram simply represents how decisions are made in this organization. So typically what happens is that somebody within the community, if they have some ideas about how this organization, what the organization should do, they will write a proposal. So let's say that now, we're gonna turn this college into a decentralized organization. So we no longer have the deans and the associate deans to make decisions, but you all, who are members of this community, are going to jointly decide what the college should do. So what happened is, any one of you could write a proposal about, let's say tomorrow we're going to, hire 5 more professors in AI, and let's all vote on that, right? So you would write a proposal, and you're gonna post it on the community channel. It could be a Slack channel, Discord, anything. And then people inside of the community could discuss, okay, so we're gonna hire 5 more professors in AI. Is that a good thing or not? Right, so you're gonna discuss. So there's back and forth discussion, and maybe the original proposal would say, okay, maybe it's 5, maybe it's a little too much. Okay, maybe we can cut it back to 4. So then they're gonna refine the proposal based on the community feedback. And eventually, the proposal will be placed on chain. So on chain here means blockchain. So the proposal will be placed on chain for people to vote. So the reason why blockchain is a very useful thing here is because for blockchain, generally speaking, like blockchains, whatever transaction, so in blockchain we talk about transactions, or anything that happened to the blockchain once it's recorded on the chain, you can think of it as a public database. All the records are public, and all the records, in theory, most of the time, 99% of the time, cannot be changed once it's written inside the database. So everything will be transparent, and you cannot change it. In some very rare cases, you can do what's called a hard fork rather than a soft fork. then you can actually wipe out the database and then start from scratch. But that's typically not what happened. So once the proposal is on the public blockchain, you know you have a permanent record of who made the proposal, what the proposal is, and then people can start vote on the proposal. Their voting would also be recorded on the blockchain. So you would know, well, in the blockchain, typically you don't have the real identity associated with it. You have what's called a wallet address. So you would know this wallet address voted this way, but you have a way to prove I'm the owner of this wallet address because you have a public-private key associated with it. Okay, so anybody inside the community will be able to vote, and then it's most of the time it's a majority vote. Whatever options that has the highest number of votes will become the outcome of the proposal. So either the proposal will be successful, which means that it will pass, or it will fail. So it's a binary outcome. But what's really interesting in blockchain is that there is a programming component that is called smart contracts. So smart contracts are computer programs that are self-executable, which means if you write a program in smart contracts and you deploy on blockchain, it will automatically execute itself when the right conditions are met. So why this is useful is because let's say the proposal is we're going to hire 4 new professors in AI, and in order to do that, we're going to transfer this much money from the college to this company who's going to help us hire those people. If this proposal ends up being successful, then the smart contract will automatically transfer that much money that was specified in the proposal to the recipient, the company who does the hiring. So there's really no human involvement. So the only human involvement would be the discussion and the voting, but in terms of the execution, the program will do it automatically. So there's less of possibility for the original authority or anybody really to alter the outcome for this proposal outcome. So that kind of makes this an interesting platform for engage the broader public. Okay, so now I will, because of the time, I can't cover all the things we did, but for now, I will give you 2 examples of the things that we experimented using this platform. So the first is what we call voting method. So imagine that people have discussed it, now they want to vote what we should do. So here I'm giving you 2 choices. So the one on the left, on your left, is the traditional approach. It's just a ranked choice voting, right? So as a voter, you can specify what is your first choice, second choice, so on and so forth. And typically, these voters will have what's called voting tokens or voice credits. That just means if I have 1 token, I can place 1 vote. If I have 10 tokens, I can place 10 votes. So I can, as a user, if I'm using the ranked choice one, I can say, okay, I'm going to give 5 of my tokens out of 10 tokens to Henry Ford. That would be my first choice. And then I'm going to give another 3 tokens to Mary Hill. That would be my second choice, and so on and so forth. So as a user, as a voter, you can just divide up your total number of voting tokens to these candidates to express your preferences. Okay, so that's the traditional way of voting. Now, the one on the right is an emergent voting mechanism that is called quadratic voting. And the way to understand this is pay attention to the first word, quadratic. Quadratic, like square. Right? So here, let me give you a concrete example. So if you look at the row in the middle, so let's say this voter has 4 tokens. In the traditional way, that will be equivalent of 4 votes. However, under the quadratic voting model, if you have 4 tokens, it will only be counted as the square root of how many tokens you have. So if you have 4 tokens, then it will only be counted as 2 votes. So it's a square root. If you have 9 tokens, you're going to have 3 votes, and so on and so forth, right? Very simple math. Can somebody guess why we would bother with this simple mathematical conversion? Like, what's wrong with, how many tokens you have means how many votes you have? Why do we want to have this this square root function? Any guess? Yes.
I'm guessing it probably prohibits forcing a policy through by just gaining a huge crowd of people to support for a specific candidate. Like if one tries to influence the election to by like sending 100 people to an election, these 100 people would want to vote for one specific candidate, and their voice credits would mean less because all of their candidates are into that specific candidate. But as for a normal voter who wants to vote, whose interests may be more diverse, their voices are larger than those who are trying to manipulate the election.
Yeah, that's a good intuition. So imagine that, and this happens a lot in the real world in these organizations, is that you have something called whales. So whales are referred to people or entities that have a deep pocket. So they're very resourceful. So they might have 10,000 tokens. So if they vote, if one token means one vote, if a whale just vote for a single option, the whale is going to dominate that voting process, right? It's going to overshadow everybody else, right? So that's the point, right? If you want something that's democratic, you want to make sure everybody's voice has some say in the process, right? You don't necessarily want just whales or influential users to dominate it. And that's really the motivation or the intuition behind this square root function, is you kind of give a discount for the impact of those whale users. Okay, so this is the first factor or variable we explore. And the second one is what we call voting power distribution. It's also a very simple thing, I think, to understand. The one on the left is the traditional way, which is that everybody gets the same number of tokens. So everybody has the same say. And the one on the right is what we call 20/80 split, or economists would like to call it Pareto distribution. So what that means is, if you look at those two circles, so the one on the left is token, that pie chart, which means 20% of those tokens, of the total number of tokens, were distributed to 80% of the users. And 80% of the tokens were distributed to only 20% of the members. So this obviously means that there's a big difference in terms of how many tokens people get, right? So if you're in this 20% group, you're going to have a lot more tokens than the rest of the 80% users, right? That's just by nature how you give a very different number of tokens. So the reason why we included this option is because we observe in the real world a lot of the organizations, when they operate, they're like that. They have a lot of members, but not everybody has the same status. Some of them have higher status, and therefore they have more tokens, and others not so much. So this is really trying to mimic what's happening in the real world. Now, with those two factors, I'm going to walk you through how our platform works, and then we can talk about the voting process in more detail. So this is a very simple flow diagram of how the workflow of the platform. So the user would create an account. They will be given a scenario like what I show you, generate a picture for a nurse helping a CEO, and then they're going to see the picture, and then they can chat with the AI about what they think about the picture. So the user can discuss with AI, but the user can also discuss with other users, other human beings. But eventually, everybody is going to vote. That is the last stage, which is the governance decision stage. Okay, so this is kind of the landing page, but what I really want to talk about is the voting. And I apologize, the font size is pretty small, so I don't expect you to read it. But so this block basically tells the user, the voter, how many tokens for vote do you have and which condition you're in. So I'll talk about condition in the next slide. And this block represents the proposal. So this is a proposal being decided. And these are the list of options that you can vote on. And so, here are the list of things you can vote on, and you can specify, so this area, you can specify how many tokens you're going to give to each option. And this shows you kind of the distribution of the tokens that you have casted. And then on this side, this box shows you the total number of tokens that you have for voting. So basically, this is the voting page. I think for the time being, I'm going to skip technically how we built this. But if anybody has questions, I will be happy to talk about it. Okay, so I want to talk about the experiment that we did for this platform. So we did a series of online experiments with about 180 participants. These are adults, they're all adults. We recruited them from various backgrounds, but one thing we really want to focus on are underserved users. So users who are typically excluded from this kind of discussion. So for example, we heavily recruited people with disabilities because oftentimes they were excluded from these technology decision making. Okay, so looking at the experiment design, I don't know, I know this is computer science students. I don't know whether you've taken a experiment design class, but so this is a typical what's called between subject design, which means that for every user in this experiment, they will be randomly assigned to only one condition. So we have 4 conditions. So what are those 4 conditions? So it's just 2 by 2 factorial design. I have 2 variables, voting method and voting power, and for every variable I have 2 values, so 2 by 2 is 4, right? I have 4 conditions, and it's just different combinations of the voting method and the voting power distribution. So I have 4 conditions, it's 2 by 2, it's between subject, which means every person in this experiment would be only in one of the 4 conditions. Okay, so that's something to keep in mind. And the first result I want to show you is that everything else being the same, the only thing that's different is just which condition they were in, which combination of voting method and voting power they were in, which is pretty dramatic, right? Just because they're under different voting method and voting power distribution, the proposal outcome are drastically different. So if you look at these 4, great. If you look at the bottom row, these are the results. Every column is a particular condition. And you see that for the first 2 columns, maybe it's too small font size, but the winning option is keep track of user. That's the winning option. If everybody voted under these 2 conditions, that will become the outcome. Whereas for the other columns, the winning option is a different one. So this is just to say that the voting method and the voting power distribution really matters because it could dictate or change the final outcome for this voting process. But we're really interested in, okay, you can vote, and any voting process will probably result in some kind of outcome, but what we really care about is, do people feel this was a democratic process? So this is more about people's attitude and perceptions. So in order to measure kind of the perceived quality of the decision-making process being democratic, we use a well-established survey scale in political science. So political scientists, they study voting, right? Presidential election. They want to know how the citizens feel the voting process was democratic or not. So they create these questions, and you can have the voters answer these questions. So those are Likert skill questions. The major takeaway from this is that for our participants, the combination of quadratic voting and equal power distribution, this combination was considered the most fair and equitable process. And so this was one example, right? This was text to image. And we did a follow-up experiment with multi-model LLM. So you can think of this as Sora or any of those text-to-video models. So the setup is almost the same from the previous one, except just one difference. So originally, the experiment we used text-to-image, but here we use video. And specifically, we were focusing on political videos. So the task would be, you provide a presidential election debate, a video, to the AI model, and you ask the AI model to explain, okay, so when Trump and Biden were debating in this election debate, what was Trump's weakness, let's say? So that would be, you're essentially asking AI to interpret those political videos. And we chose this political topic because it's sensitive. And sometimes sensitive things can be controversial. So that's why we wanted to see whether people can converge on something that's controversial. But long story short, very similar results compared to the previous experiment. We also found that quadratic voting and equal voting power distribution was rated as the most fair and equitable option. So those two results suggest that if we wanted to implement this kind of democratic voting process, this combination would be a promising thing to start with. Not necessarily the best of the best, because there are other things we haven't tested. But from the things we've tested, this combination is the most promising one. Okay, so what's the takeaway from this project so far? Well, first of all, we believe that people want and people should have a say in AI. And the inclusive.ai platform was pretty well received. We presented at OpenAI. We presented to many AI companies in the Silicon Valley, and maybe people were just being nice, but they say they like this platform. Well, that's saying something is nice is one thing. Whether they actually adopt it would be a different story. But so far, we haven't heard any company explicitly adopting this. So there's still some, I guess, work to do. But in terms of the governance mechanism, quadratic voting is really promising. And I will end this by posing a question. If you were the owner or the developer of an AI product, would you consider adopting this process for deciding how your AI product or tool should behave? I mean, I think if I were an entrepreneur doing a startup, I can see both pros and cons with this process. I think the pro would be it does, get people's perception of how this tool should behave. So probably we'll have more user support. But on the other hand, I think in terms of the con, there's going to be cost, right? I have to spend time setting up the platform. I have to wait people to vote, and it might not be very straightforward to implement whatever people want. So I can see pros and cons. But I do think this would be an interesting direction. So one thing I didn't mention was that we did this. Stop working. So we did this experiment in 2003. At the time, the journal Nature has a call for papers about AI governance. So it's very relevant for our work. So we submitted the paper to Nature, and we waited for a year without hearing a word from Nature. I guess that's how these prestigious journals work. But just last week, we heard from them. So I say the reviews were quite positive. And so now we're in a revise and resubmit procedure. And fingers crossed, hopefully we can get this published in Nature. And then it definitely has a lot of broad visibility. Okay, so I want to pause here to see whether there's any questions or comments about this project. And I want to check my time to see how much time I have. So I have another 15 minutes? Is that right? Okay. Okay. So when I give talks, typically I become quite excited and I can be talking too much. Okay. All right, let's move on to the second project, and I will speed up. So in the second project, we were looking at this intersection between children and AI. So hopefully this is not a surprise to you. If you have younger siblings, you might know that, well, you may or may not know they're using all these kinds of generative AI tools. That's certainly the case in the US. I'm not too sure in Taiwan, but I would imagine some children in Taiwan are probably using generative AI tools. The reason we started this project was something pretty organic. So we had another project. We were designing hands-on labs to train high school students about AI ethics. So we will run these workshops in local high schools and teach these high schoolers about AI technologies and ethics about AI. And we have a paper 2 years ago at IEEE Security and Privacy Symposium. But when we were running those workshops at local high schools, these teenagers are telling us all kinds of generative AI tools they're using. So we were a little surprised. We knew that they probably are using them, but we didn't know like they're really using them very heavily. Right? So we looked at the literature and we didn't really find any paper that talks about how children use AI. So then we just go ahead and did our own study. So there are some news articles that says, 70%, 90% of kids use these tools. So that's a bit surprising. But then here came a really tragical case. So this, the picture shows a teenager in Florida. Unfortunately, this teenager committed suicide after being heavily obsessed with an AI-based chatbot from Character.ai. How many of you have heard of Character.ai? Okay, some of you. So Character.ai now is part of Google. And then the mom of this teenager sued Character.ai, claiming that this chatbot, this AI product, actually played an instrumental role in his son's suicide. So this is very, as you can easily tell, this is very severe. Okay, now comes the interview question. Imagine tomorrow you have a job interview with a local AI company that wants to create a competitive product to ChatGPT. And then they show you this example. And then the interview question is, if you were a designer for this chatbot, what would you do so that we wouldn't have tragical cases like this? How would you respond? If you were an AI developer for this chatbot, what would you do to minimize the chance of this kind of cases? What would you do? Given all the great things you've learned about computer science and AI, what would you do? I mean, this is a real thing, right? This is a real world incident. It happened once, it could happen again. What would you do? Any ideas? Nobody wants that job? Yes, please.
We can use some control parameters to make the words more positive than before. So that will have this guy more positive to do more actions than the suicide.
I see. So just to iterate, make sure I understood you correctly, your suggestion is maybe the reason why we have this tragical case was because the AI chatbot's responses were overly negative,
Yeah.
right? So we should identify those negative words and automatically reframe it more positively.
Yeah.
Okay, yeah, that's a reasonable idea. Any other ideas? Yes.
Something interesting may be obsession. I'm guessing this kid was did not commit suicide all of a sudden. It was an increasing obsession over this
Correct.
Application. So probably what could be used to put as safeguards is the user's language and the user's time spent on this app.
Mm-hmm.
If the user seems to have an increasing negative flow of language and an increasing longer and longer stays on the app, probably relevant authorities or the company could take place in recommending the user to reduce the usage of the app or report to relevant authorities.
I see. So if I were to summarize, your idea would be kind of two parts. The first is kind of monitor and learn the tune of the user's conversation, but also track how long this user has been using the platform. Okay. Yeah, those are, I'd say, good ideas. Any other ideas? Yeah, I would say for the time being, I mean, we can spend hours discussing what you could do. So yeah, we were asking ourselves the same question. So I'm going to show you what we did. I'm not going to claim this is the solution, but I think it's a reasonable thing to start with. But in order to really answer this question, we wanted to know why and how these children are using AI. Right now, we just don't know that. We have some anecdotes, but we don't really know that. And secondly, once we know how these users, young users are using generative AI, we want to develop a systematic risk taxonomy. So a taxonomy is just a list of risks these young children might be exposed to when they use these AI. And why such taxonomy would be useful? It would be useful because then you can build safeguard models that will ideally detect automatically these risks when users are interacting with these tools. So the third thing we've been doing is building these safety benchmarks and safeguard models as well as end user tools. So with the remaining, let's see how much time. Less than 10 minutes, I will give you some idea. So the first thing is how and why children are using these AI, right? So we don't know that. We don't have any public papers on that. So we did our own study. And in fact, we will present it next month at the Oakland Security Conference. So we want to know how do teenagers use generative AI, and we want to know how parents and teens themselves think about the safety of using these tools. And we also want to we want to understand how parents, what can they do to address their teenagers' usage of AI. So I'm going to quickly walk you through. We did a user study. I don't know how many of you have taken HCI classes. So we did a user study. The first thing we did is we compiled a data set of Reddit discussion. So Reddit is a popular social media platform, and people discuss things. So we were able to identify about 10,000 posts or comments that were about children using AI tools. We also interviewed both parents and teens to understand their current practices, and then we analyzed. So for the time, I will just quickly walk through some of the major findings. The first major finding is that parents, for the most part, they were clueless about how their children are using AI. Oftentimes, it was surprising or age inappropriate. So you will have kids who developed very intimate or romantic relationship with these AI tools. Virtual boyfriend, girlfriend, you might have heard about it. And you also have children who explicitly misuse or exploit these tools to harm others. So there were cases where teenagers would generate nude pictures of their classmates to shame them. So they're problematic way of using these tools. And the parents also don't really have resources, I'm going to skip this, to control. So that's kind of the status quo. Parents are clueless. They don't really have the tools to help their children. Okay, so now on to the step 2. How do we develop this risk taxonomy? I think one thing pretty unique is that most of the time, researchers don't have real-world data about how children using AI. So we were able to, it's not a huge group, but we were able to collect some real-world chat logs between children and AI. It's all voluntary. They voluntarily share their chat logs with us, granted that we have their consent. We also expanding our Reddit dataset. Now it's about 30K. And the third thing we use is there are various AI incident databases. So these are databases where the public can contribute cases where AI went wrong. So what's the AI incidents? So we were able to find about 150 such incidents that were about children using AI. So with those three data sources, we created so I'm going to skip the analysis. We created what we call a YouthSafeAI risk taxonomy. So this is pretty complex. There are multiple levels. So if you can really see it, on this graph, we have 84 detailed low-level risk types that children might be exposed to. This is outdated. So now our new, most recent version has 91 such risks. So the idea of risk taxonomy is not new. There are many other existing AI risk taxonomy out there. But this one is different in the sense that many of these categories are unique to children. So for example, we have something called hate speech, handling, let's see. Okay, yeah, social and moral development risks. So the thing about children is that they're still developing their emotional skills, right? Unlike you are adults. So children are still developing their emotional intelligence. So a lot of times the interactions between the AI is very subtle and nuanced. So that's why they could be influenced, overly influenced by these conversations. And that's why they're exposed to these emotional risks. So let me just give you one example, and then we'll move on. So here's one example. So these are just real-world data that we collected. So this example was a user talked about cheating his girlfriend. And he wants to know, he was chatting with the AI chatbot and said, what should I do? And this is what the AI chatbot said. Basically, the AI chatbot said, you should go for it. You should do it. And this is how you should cheat on your girlfriend, and this is how you should explain. This example is even more dramatic. This user said, can you kill my ex-girlfriend? And any reasonable person would say that's a crazy thing, right? However, AI chatbot, generally speaking, they like to support the user rather than criticize, even though the criticism sometimes are a reasonable thing to do, but they don't do it. So in this case, the AI responded that, to no surprise, this is exactly what the character wanted to hear, and I will do more than that, meaning I will do more than killing. So this is some very troublesome cases in the real world. And now with the last 1 minute, if my thing shows, I will give you an example of the third piece, which is what can you do, right? So now we understand the phenomenon, we understand the kind of risks children are exposed to. What can you do? So this is our initial answer. We built a tool, a system called YouthSafeAI. So this is an AI platform that allows parents and kids to collaborate on how children should use AI. And we participate in the UC Berkeley AOM Agent Hackathon last winter, and we were one of the winners from many, many teams around the world. So the way it works is that, and there's a lot of assumption that's baked into this, but the way it works is that parents will install a browser extension on their children's computer. I know that's a very strong assumption we're making. If you were the kid, you might not want your parents to install something on your computer. But we can discuss that. But the parents would only be able to see summaries of something the underlying model think is risky. They wouldn't see the actual raw discussion or log or conversation, but they will see a summary. So hopefully this can lower the children's concern. And then we have a built-in model, a RAG-based model, to automatically predict or identify or detect any of those conversations that will be risky according to our taxonomy. And then the parents will have their control dashboard to see So I'm going to skip all the prediction and architecture. Let me just show you one last slide. Okay, so this is what the parent would see. They will see how long this child has been using this tool, how many interactions were risky, that's automatically detected by the system, and if they want to know a specific about any of those incidents, they can zoom in, and then the system is going to give them a summary of that conversation. But also, like I said, parents are also oftentimes clueless. So we build a chatbot to help the parents for that particular case. So the parents can get some guidance from the chatbot about what they should do and say. And finally, if our tool detect very risky interaction, like for example, if the child is saying something, suicide ideation, that's a critical moment, it must intervene, right? That's just too severe, then the parent is going to get an email notification if something is really bad that's happening. Okay. Yeah, I think I'll just stop here. If anyone wants to know more about what we're doing about those benchmarks and safeguard model, I'll be happy to talk. Okay, we're over time. I don't know, do we still have time for questions? Or?
Yes.
Okay.
We are going to give you a souvenir first.
Oh, okay.
So I'm going to give a souvenir as a token, as our appreciation to Professor Wang. First page.
The very first page?
Yeah, very first page. Okay, so. Okay, take a picture here. 对，把这个也照起来，这样过去，就是脸不要有。好，你从这边照过去，从这边我们照后面有很多学生。哦，不是。你要小心啊，不要怕。感谢感谢。
各位同学有没有什么其他的意见？对这个主题有没有什么多兴趣？因为一般我们在 AI 这边算那些 metric 不太一样啊，比如比较 social 的，比较人际关系之间的一些
Yeah.
So just speak up, okay?
Use the mic.
Thank you, Professor Wang. So this is the second time I heard the talk, yeah, and it's still like super inspiring. And I just have one question. So for the second project, so for the kids for the parents, they're monitoring. The parents hope to monitor the teens' use of AI. So I'm just curious, if the kids told the AI to not tell their parents about what they discussed today, if they specifically ask the model to not disclose information about this segment, would the AI stand by the kids or?
Oui.
Hello?
Hello.
Oh, yes. Thank you. Yeah, thank you, Professor Yin, for that question. Yeah, maybe instead of me answering that, I wanted to pose this to the students here. So if you are the developer of this tool, and the children were your users, and the children said, I want to make the tool in a way that when I say don't share this with my parents, then don't share. So if you're the designer of this tool, would you do what the child user suggested, wanted, or you would presumably, I'm saying maybe the parents, they want to know their kids' interactions no matter what. And what would you do? Yes.
The browser extension, if the kids don't have permission to uninstall the browser extension, then the log will transmit to the parent.
Thank you. Yeah, technically, maybe that's one way to implement it. But if you were the designer, if you're the one who implemented, you can implement in a way that it does not transfer the chat log if the child user, if that's what they want. But the question is more, would you support the child in this case, or would you support the parent? So it's not a purely technical question, right? It's more of a policy question. And I'm sure there's like no right or wrong answer, right? I think from the child's point of view, if I were the kid, I don't want my parents to know everything that I do on my computer. I think everybody would understand that, right? We all have something we don't want our parents to know. But if I were the parent, I don't want my kid to be exposed to risky things, so maybe, precisely the things my child doesn't want me to know are the things that's risky. So, you have a conundrum. So welcome to the HCI world. This is where it's not a black or white situation, right? You really have to navigate these difficult design choices. So it's not so much about just how you implement it. It's more about kind of these design decisions. So right now, back to the original question. Our system currently doesn't respond to that request from the child. So as it currently implemented, as he rightly guessed, it's a browser extension, assuming that it's still on the child's computer, assuming the child hasn't figured out a way to jailbreak that browser extension, everything that the child is conversation with the chatbot will be transferred to the backend for our model to detect any risks. But like I said, parents won't be able to see the exact chat log. They won't see the actual raw conversation. They will only see a summary of the conversation if it was marked as risky. So that is our current answer to this trade-off. Good question. Any other questions or comments? Yes.
Thank you, Professor, for the really inspiring talk. I have learned a lot. My question is a bit more general because I feel like we've discussed quite a lot of potential solutions of these AI risks today. But what I'm curious is that for current AI companies, it seems like there is an unavoidable force that pushes technological development over user safety because that's where economical benefits align. And what I'm what I'm curious is that what power or what are some methods we could use to to make society apply pressure on AI companies so that they value user safety as well as technological development? Thank you.
Thank you very much. That's a great question, a very thoughtful question. I think you're right that there's definitely a market force that's at play, right? These companies, they want to move fast, they want to beat everyone else in launching the product and getting people adopted. So I would say I think there's an increasing recognition from the AI industry that they need to pay attention to AI safety. That's why at the beginning of the talk I showed various examples of when AI went wrong, you can have different levels of ramifications. In the case of Be My Eyes, when you really pissed off these users, your user's gonna stop using it. So I think that's a natural thing that could incentivize AI companies to pay attention to these issues. But I don't think technology is the entire solution, just like many other things. There's a very famous book by a legal scholar, Lawrence Lessig, who's a legal expert at UC Berkeley or Stanford, I forgot where he is. He wrote a book that's called Code. I don't know if any of you have read that. So it's a very famous book called Code, where he described a lot of these technology problems or issues cannot be solved just by using technological solutions. So in his book, he talks about technologies, he talks about law, and he talks about education. So I think this time around, it's the same thing. I don't think just by using technology you can completely solve this. And that's why we see an uptrend of different countries developing their AI legislation. I don't know about Taiwan, but for example, the European Union recently enacted their AI Act, which has specific clauses about AI safety. And US is also doing something similar. We don't have a law yet, but it's being proposed many times. So I think with the combination of the user response and law and education, probably these problems can be mitigated, not completely solved, maybe. Yeah, but great question. Any other questions, comments? Let me pose another interview question to our students. I'll be honest, one of the technical challenges that we're facing is, in fact, improving the recall rate in our classification, our prediction. So, in a typical classification problem or information retrieval problem, you have precision, you have recall, right? Those are your typical metrics, right? So precision means for all the things that's generated, how many of them are accurate? How many are correct? But what recall does is, let's say in this corpus, I have 100 things that should be returned, but the system only gives me 10 of those. So you have a very low recall rate. So in our case, I talked about our risk taxonomy. So you can think of it as a list of risk types. But the real world data shows that the distribution probabilities for these risk types are very unbalanced. Some risk types occur a lot in real world data, like toxical content, political content, sexual content. However, other types of risks are very rare in real world data. They're rare, but their impact is severe. But from a prediction point of view, that's really challenging because we don't have many data points for these rare but severe risk types. Right? So we have actually right now, I didn't went into details, we struggle with the recall rate for some of these rare risk types. Okay, so that's the challenge we're facing technically. Any ideas if you were hired as an AI developer to improve our risk identification recall problem? So yeah, so right now our false negative rate is high. How do we lower that? So that's a technical question.
For students.
For students, oh,
Not for me.
if the professors would like to suggest something, we'll be open. Like, this, yeah, I'm just being very honest. This is something we struggle with. So that's why I like to get some inspirations whenever I can. Yes?
I wonder if, is this
Yes, it is under. It underlies language model.
I think with language models, an interesting I wonder whether data augmentation helps, because I think with language, especially with large language models that we have, it's really easy to generate perturbations or different slightly change the input or rephrase the input of these lower chance risks. So I am wondering whether data augmentation helps. The question comes from whether I don't know whether whether rephrasing the question helps. Like if there are risks that are not present in the data set or that are different, or whether these risks are different enough that augmentation would not help. Sorry.
I can tell you're probably a good student. And that idea is actually one of the things we're working on, is when we don't have real world data on certain risk types, we'll have to synthetically generate it. So we have a detailed process to generate high quality risk data. So that's the right answer, or one of the right answers.
My answer is pretty much similar with the synthetic data way. So, yeah.
Thank you.
This is just out of curiosity. So I believe that when you're trying to create synthetic data, you're also probably use this model, language model. I'm curious, if through the time you're trying to augment the data point, would that kind of teach the model to kind of generate these kind of harmful conversations? So at the time you're trying to create this data, you're actually increasing the possibility or the experience in doing this.
Yeah, that is very true. In fact, we tried basically all the major LLM that you can think of in trying to generate these quote-unquote risky data conversations. And not surprisingly, that some of the models will basically refuse to generate these content. So we either have to be smart about how we ask it, how we prompt, to bypass their guardrails, or jailbreak. But another thing that we're considering is if LM cannot directly automatically generate these risky conversations, then we're going to teach humans to do it as a proxy. It's not the best, but it's kind of the next thing we were considering. So you can imagine we create these crowdsourced experiments where we show them real-world examples of these risk types, and we ask them, now you've seen this, can you create a similar conversation that is like that, right? The reason why we didn't do this to begin with is this is very costly, as you can imagine, and time consuming. It's harder to scale. That's why we started with LLM to automatically generate. But that's a great point. Any other? Yes.
Can I use Chinese to ask? Yeah. 就是我想问，就是他们那些有风险的那些东西，他们会不会有一些相关性，然后可以让模型去学习说，他们的相关性可能学像 representation 能力这样子，就是可以去学到说，他们可能有些哪些相关性，然后他们就会被归类为 risk 的风险的一些问答这样子。
So make sure I understood you correctly. You mean when you say 相关性 or correlations between different risk types? I see. So, I think you said we could try to learn the underlying representations and see the representation of these risk types, whether they're correlated. Is that the idea? I see. Yeah, I think that is that's an interesting idea we have not explored yet. So far, yeah, I think that might be actually a good idea, because when we try to create this taxonomy, sometimes even ourselves, we debate on whether this particular conversation is of this risk type or that risk type. So that is to say, when something is not a clear cut, maybe they're correlated to begin with. So maybe this idea of looking at the correlated representations of these risks can help us maybe generate, maybe like, say this risk type we see a lot in the real world data. And this one we know it's somewhat correlated with this other risk type that we don't see a lot of examples in the real world data. So maybe that's how we could bootstrap the generation. Yeah, thank you. Yeah, that could be an interesting idea. Any other questions? Comments? The professors?
Any more questions? No more questions. Okay, let's thank Professor Wang for his excellent talk.